All right, guys, so we're starting a new chapter today. This is going to be talking about cylinders and cones for most of it. We're going to find area and volume for these. I want to start off looking at the cylinder. We've got one over here to the right. I mean, you've seen plenty of cylinders in your life. You should know what they are. But this over here to the right, this is the net of a cylinder, okay? Like, if I take this cylinder over here and I slice it down like that, you have two circles for the bases, but that circular sides or the walls will lay out flat into this rectangular shape over here, okay? So really, we only need two things to do things with cylinders, and it makes it pretty easy most of the time. The first, we have to know what the radius is. So you kind of have two opportunities. The top and the bottom will always be congruent, so if you find one, you have them both. And then the other part is the height. Now, it kind of has an arrow here. This height right here is this height right here, okay? So the height of the cylinder. It's going to take me a while not to say prism. So we're going to find three things on this. Lateral area, that's the area of the walls, just this curved surface that goes around without the bases. Well, the formula is 2 pi RH, but if you notice, we've seen this before. That's the formula for circumference. So it's really the circumference times the height. So all you need is R and H. Now, total surface area, it's the same as before. We want to find the lateral area, but we want to add to it 2 times the area of the base. So that's going to be finding the area of one of the bases and multiplying it by 2. So you're adding that into your area. And then volume is still big B times H, but in a cylinder, the bases are circles. So we use the area formula for a circle times the height. So let's look at one. We're going to do 3 altogether. It says, for the cylinder below, find the exact lateral total surface area and volume. Guys, when it says exact, I still have people asking me this. It means leave pi in your answer, because if you multiply by pi, it's not exact anymore, because even though your calculator shows you some decimals, it goes on forever. So, 2 things we need to find. First, the radius. Well, luckily, it gave it to us this time. It looks like it's 3 inches. And we need the height of the cylinder. Looks like in this case, they gave it to us as 6. Now it's just about throwing it in the equations and solving. So we're going to start with lateral area. Lateral area is 2 pi RH, so 2 pi times the radius times the height. So the pi is going to be there. Don't leave it. Basically, you're just multiplying 2 times 3 times 6, which ends up giving you 36 pi. So I come over here, and I'm going to do something a lot of you forgot to do on the test. The answer is 36 pi, but that's going to be inches squared. So please, guys, be careful and put your units. Now we need total area. Well, we already found half of it, 36 pi. But if we look back up the formula, it's plus 2 pi r squared. 2 pi times 3 squared. So I'm going to break this up into a couple of steps. Of course, you may not need to. That gives me 36 pi plus, well, 3 squared is 9. 9 times 2 is 18 pi. Now, since they both have pi, that's like adding 36x plus 18x. I got 54 pi, which of course is also inches squared. Now we're going to move over into volume. You can think of it as big B times h, but you can also think of it as pi r squared h. So pi times the radius squared times the height. Well, that's 9 pi times 6, and 9 times 6 is 54 pi. So I have 54 pi, but this time it's inches cubed. So be careful, guys. We've been working on this kind of stuff involving pi. Make sure you're using it correctly. Let's go to the next page. Now, these two are a little bit different because we're going to have to do a little bit of legwork. Remember, I need R and I need the height. Well, they gave me the height. It's 5 feet. That was pretty easy. But they didn't give me the radius. Now, you're looking at this from an angle, okay? So this triangle might look like it's some sort of 30, 60, 90, but 2 of the legs are the radius. So they're the same thing, meaning they're both x. That means that we have a 45, 45 triangle. So if that's the case, then this is our x square roots of 2 side. So that makes it pretty easy to find the radius. If x square roots of 2 equals 3 square roots of 2, then my radius must be 3. And now, guys, we're going right into the same thing. It's almost the exact same problem. So let's do those 3 things. We'll start with the lateral area. That's going to be 2 pi times 3 times 5. I'm just using the 2 pi RH from the beginning. 2 times 3 is 6 times 5 gives me 30 pi. Now, of course, it was feet this time, so feet squared. Now let's find total area. We already found half of it with the 30 pi. Now we just have to plug in r into 2 pi rh, or I'm sorry, 2 pi r squared. So I have 2 pi times 3 squared. That gives me 30 pi equals 9 times 2 is 18 pi. And again, I can add those together and get 48 pi. So my total area is 48 pi feet squared. And then the last one's volume. That's 2 pi r squared times h. Pi times 3 squared times 5. Well, that's really 9 pi times 5, which gives me 45 pi for my volume. 45 pi feet cubed. So those are pretty straightforward. Even finding the radius when it's not given wasn't so bad. And this is probably the worst one. It's the same questions, exact lateral area, but remember these are equivalent because they're radius, because they're radii, and I have a 45, 45, 90 triangle, but this time they gave me the x squareds of 2 side is 4, so we have to do a little legwork. Now I'm going to do the whole thing. We need to find x. First, I divide by the square root of 2 on both sides, but we can't have that because radicals can't be in the denominator. So I multiply it by the square root of 2 over the square root of 2, and I get 4 square roots of 2 over 2, but I can simplify, and I get 2 square roots of 2. Now, I know I went through that pretty quick, but we've done that a lot. Remember, just take this number, divide it by that, and put a square root of 2 on the end. So now I know the radius is 2 square roots of 2. So I can find all my stuff now. I'm going to write those out so don't forget. R is 2 square roots of 2, and it looks like H is 4. So this might cause us a little bit more trouble, but just pay attention and make sure you take your time and don't screw this up. So the lateral surface area, 2 pi times the radius times the height. So this square root of 2 is going to still be on there. There's nothing there to make it go away. I'm going to multiply 2 times 4, which is 16. Then I have the pi and the square root of 2. So guys, you can put these in any order you want. I don't care, but make sure they're both there. 16 pi square roots of 2. What are our units? Centimeters squared. Let's look at total area. Again, we're bringing down this 16 pi square roots of 2, but now we're adding to it 2 times the area of the base. Pi times 2 square roots of 2 squared. Now here's where people messed up again, this part right here. I'm going to write it up here. This is 2 square roots of 2 times 2 square roots of 2. 2 times 2 is 4. The square root of 2 times the square root of 2 is 2. That means I get 8. So I have 16 pi square roots of 2 plus 2 pi times 8. And of course, 2 pi times 8 will be 16 pi. So I have 16 pi square roots of 2 plus 16 pi, and that would be centimeters squared. It's a pretty tough one, but really if you just take care of this part, it's not so bad. See, volume, that's going to have that radius in there again. So it's going to be pi times 2 square roots of 2 squared times the height, 4. Well, I know 2 square roots of 2 is 8, so I really have pi times 8 times 4, which is 32 pi centimeters cubed. So guys, if you're having any troubles with this, of course, we can talk about it on Monday, and good luck.